Hey, this is Kevin with AGL, and we are going today to show you how to program your 14SG, Futaba 14SG, nice brand new radio with a broken switch on it, with your Naza V2. We did the previous video with Spectrum DX9, setting it up on the Naza V2, and today we're going to do this for our Futaba guys. If you've got a 14SG or an 8FG, then this will all work pretty much the same for you. Alright, so we're going to start out by taking our radio and binding it to the receiver on the aircraft, which is already installed and working with Naza. So just make sure you're to that point. If not, then you just stop and look at one of our other videos on how to actually set up, install all the wiring for your Naza and hook it up to your receiver. So we're going to start out by turning on our radio, and we're going to set up our model. Okay, we have a new model set. To do this, you hit link twice, you scroll down to select model, hit the center button, and we're going to go over to new, and we'll make a new model. We just made this one, so we're going to select it, and we're going to exit out. We got our home exit button over here. Hit it twice, we go back to this screen. So we've got our new model. We need to set up a couple things. We want to set up our mode switch. I'm going to set up my mode switch to be on SE right here, this 3-position switch. One of the things that I'm going to do is set it up to where the farthest position back is GPS mode, the middle is attitude, and the closest in is failsafe. If you prefer, you can set that to be manual or however you'd like. And then we'll set up a true failsafe as well. So we'll have a switched failsafe and a true failsafe if we lose connectivity with the radio. One other thing that I'm going to do is take this nice slider that we have here with our Futaba and set it up to control our tilt for our gimbal. And we can do all this before we ever power up the aircraft. Okay, we're going to start by hitting our link button twice. We're going to go down to function. And you can see that we have our first 4 channels, aileron, elevator, throttle, and rudder, set to our normal 4 controls here. If you'd like to see the way they function, you can back out and then hit our button right over here, our other menu button, and monitor our servo travel. Now, one thing about Futaba, the throttle is almost always reversed as to what normal control is needed for either flight controller similar to this, or if you're setting up an airplane or anything, it's almost always reversed. And it's also defaulted over to having 6 mixed in with it. Now, one thing I didn't cover is that this is an airplane model. We're setting this up to be a 4-channel airplane, not a helicopter. So we need to disconnect channel 6 from channel 3. You can see that we have rudder on 4, elevator on 2, aileron on 1, throttle on 3 and 6 currently. On 5, 5 is initially set up on the SE switch, which is gear, defaulted, and for our slider we don't have it set up to anything. So we're going to back out, hit our link button twice, and go down to function. Hit the center button. We're not going to change any of this. You can either scroll through it, or you can hit down here at the bottom the S1 and page down. Now what we want to do is take gear that we want. Channel 5 is going to be X1 in the Naza Assistant. So we're going to go over and change this to our slider, our right slider. So we're going to select it and scroll all the way down to right slider. Next, we're going to take channel 6, which is currently connected also to J3, which is our throttle, and make it null. Put it to where it's connected to no switch. And then go down to channel 7, auxiliary 5. And this is going to be our mode switch. So I'm going to set this up on the SE switch right up here. So we're going to select it and scroll to SE, and we should be good to go. We can exit out, set the radio down, and plug up the aircraft, which is already connected to the computer. You can see on the assistant software that our tabs are green. We are seeing that we have control input and we're in attitude mode. So the first thing we're going to do is go over to the basic tab. We're going to start off with the aircraft type. We have the X configuration already selected. If you have another type, another setup on your aircraft, if you're flying the Ys, if you have a hex, then you just select that, and then you can move on to the next tab, or you can go down to motor test. If you're not sure that your motors are spinning the proper direction, then you can use this. Always remove your props before you do any of the motor test, so you don't have one accidentally spool up, try to flip over, or anything like that. And what this is going to do is we're going to start out, we're going to hit the tab. It's going to give you a warning to make sure that you've read the above notes before you start the motor test, that you don't have props on it. We're going to tell it okay, that we agree, and you can see that the front right arm and a quad is going to be motor 1, and that this needs to be turning counterclockwise. Motor 2 is going to be clockwise, motor 3 is counter, motor 4 is also clockwise. And if you push the tabs, then you'll see the motor start to spin a little bit to make sure that it's spinning the proper direction. We're going to close this out. Our motors are all spinning in the proper direction. We have the props on the way they're supposed to, so that's all good to go. Next, we're going to move to mounting. Mounting, we have our controller facing towards, with the little arrow facing towards the front of the aircraft. All your motor inputs, they go towards the front of the aircraft. We're going to take this controller, and we're going to make sure that it's as close to the center of gravity on the aircraft as possible. This next tab down here has to do with our GPS position. On the GPS, you also have a little bitty arrow right here that's supposed to face towards the front of the aircraft. If this is off to the side, it's off a few degrees in either direction, then your aircraft's not going to fly properly. You need to make sure that this is as true as possible. The next thing we're going to do is determine the correction that we need to make for our height and position of our GPS. On this particular aircraft, the GPS is set aft of the aircraft and off to the left. So to make the adjustments for that, we're going to go in here and look at our X, Y, and Z plane. On our X plane, we have the red line. The red part of the line goes forward of the center of gravity, and the green goes towards the aft of the center of gravity. Our GPS is set back 4 centimeters. So over here on the tab, for the X plane, we have -4 centimeters. That's our correction from the center of gravity back. On the Y plane, it's going to be left to right. If it's left of center of gravity, you have green, which is negative. If you're right of the center of gravity, which is positive, the red line. So we are to the left of the center of gravity on the Y plane, 3 centimeters. So we have -3 centimeters. And on our Z plane, above and below the aircraft, for the center of gravity, we are -8 centimeters above the center of gravity. And we have negative added to our value because we're the green line going towards the top of the aircraft. The next tab is going to be the RC tab. This is going to be the most important for setting up your aircraft. When we did the Spectrum video, we set it up as a traditional setup, so we had all the servo plugs coming from our receiver into our Naza. With this one, we're going to go with D-Bus, which works the same as S-Bus in our Futaba radios. We have one wire coming out of the S-Bus port on our receiver into the Naza V2. We select that, make sure that everything's wired up properly, and we're going to look down here at our tabs to make sure that they're going the proper direction. We see that on here, so we move our aileron left, we get left on the screen. We move the aileron right, we get right on the screen. So we move the elevator back, then our tab goes left, we move the elevator forward, our tab goes right. The throttle is all the way down, the tab's to the left, the throttle's all the way up, the tab goes to the top, or to the right. If any of these need to be reversed, you don't have to reverse them in the radio. You can, but it's much easier just to go over here and hit this tab to change it, if need be. For our rudder, we're going to move our rudder to the left. You can see our tab goes to the left. Move our rudder to the right, our tab goes to the right. Okay? So that's set. We're going to do a calibration just to make sure that our endpoints get set for this particular radio and receiver, so that it sees everything we're doing. We hit the start button and we're going to move our sticks to the endpoints all the way around. Then we're going to take them back to center and hit finish. So our stick inputs are good to go. Okay, the next thing we're going to work on is going to be our mode position switch here. Now earlier in the radio we set that up to be on our channel 7, and we set up channel 7 to be on the 3-position switch up here, the SC switch. Now you can see on the assistant software that when our switch is all the way back, we're in the blue. As we go to center, we're in attitude. We go all the way this way, all the way front, then we get the blue on the right. So we need that tab to hit GPS, attitude, and failsafe. We're going to change that in the radio by changing the endpoints for that particular channel, which is channel 7. So we hit link, we're going to scroll over to endpoints, and we're not going to mess with the first 4 channels. We're going to go down to channel 7. Right here. We're going to select it in the center button, and we're going to rotate that down until you see the tab start to move on your screen. As that tab hits GPS, that's a good point to start. I like to go another click or two just to make sure that it's right in the middle. Okay, so we've got 78 this time. We're going to hit the center button to select that. We're going to take our switch, rotate it. We still get attitude, so we have GPS, attitude, and we're too far to the right to hit failsafe. So we're going to go back over here to the other side on channel 7, hit the center, and rotate it down probably to about 78 as well to get it to move. And there we go. You can see on our assistant software we have the tab set up in the middle of failsafe. We're going to select it and we're going to back out. We're going to test our switch and look at the assistant software. So we're in GPS mode, we're in attitude, we're in failsafe. If you want this switch to be in reverse, you want failsafe to be farthest away from you, then all you have to do is reverse that particular channel, and you do so by hitting link twice, going in to your reverse tab, and then scrolling over here to auxiliary 5 and telling it to reverse it or make it normal per your liking. We're going to back out. The next thing we want to do is test the true failsafe. So we have GPS, attitude, and a switch failsafe. We want to make sure that our aircraft has a true failsafe in case we lose link with the aircraft while we're flying. Either we go too low or behind a tree, or we just fly too far away and we lose link with the aircraft. We want to make sure that it's going to come back to us. So we're going to test that by turning off the radio and seeing where our tab goes. Our tab goes into the failsafe tab, so we're set. When the radio is turned off, you can see it's turned off, and on our tab on the screen on the assistant software, we're in failsafe. We're going to take our switch, rotate it all the way back into the GPS position right here. Okay, it's all the way back in the GPS position. Radio's still turned off. We're going to turn our radio on, and we should see that tab on the screen move back to the GPS. So there we go. We're good to go. We have a good true failsafe. We have our failsafe switch and a good true failsafe. Turn off the radio. We get failsafe on the controller. Alright, we're back in GPS mode. Next thing we're going to do is calibrate our right slider over here for our tilt function. Okay, you can see that it is moving X1, but we want to make sure we get it calibrated so we hit the endpoints properly. We're going to go up here and hit start, and we're going to rotate that slider back and forth. and then hit finish. So that should be good to go. Right up here you see receiver advanced protection on and off. I always leave that on so the Naza can also assist you in detecting whether or not your receiver or the Naza needs to go into failsafe because it lost connectivity with your receiver. Each receiver is a little different. These are FreeSky receivers, the true Futaba receivers. The 12 and 14 channels, you can actually go into the failsafe menu inside your 14SG. If you hit the link and go over here to the failsafe tab, and you can select a particular channel as you're rotating through and set that channel to go to your failsafe mode. We don't have that option with this receiver. All we have is throttle hold, but we have a good true failsafe with the receiver on the radio. So next we're going to go over to gains. This particular aircraft flies just fine on the stock gains. If you need to change that for your aircraft, then do so accordingly. We're going to move on to the Advanced tab. On the Advanced tab, we always select Intelligent for the motor idle speed and the recommended setting in the center. If your aircraft, when you start it up and you try to initialize the motors, they don't want to spin or they just cog a little bit, you may need to step this up to the next tab just to make sure that you get a good idle speed. I've only had one aircraft do that, and they had really low kV motors and great big props, and they just wanted to sit there and cog a little bit instead of actually spin up at the idle speed. So you have to bump that up just a little bit. Most of the time the recommended settings under Intelligent will be just fine for your application. Next tab is Failsafe. Failsafe is what we're going to command the aircraft to do if we lose connectivity with it. We hit a low voltage, or we lose connection with the aircraft by a true failsafe, or we have hit our failsafe switch, what we actually want the aircraft to do. We can either have the aircraft land where it is, which never seems like a good idea to me, or you can have it come back home and land. With this particular one, with Naza V2 and Naza Lite, the aircraft, if fail-safe, it's going to go into a hover. It's going to either climb out to 20 meters in altitude, or hold its current altitude if it's above it, and then come back to you, hover over you, and then slowly start to descend until it gets to the ground. With A2 and some of the other controllers, you can actually adjust the altitude in which the aircraft comes back. But with Naza V2 and Naza Lite, we're going to come back at 20 meters if you're below that. And I always prefer that the aircraft at least start to try and make its way back home, so I have a better chance of getting to it. And then it's going to come back over the home position, which it hopefully saved, and start to descend. Okay, the next tab we have is going to be the IOC, or Intelligent Orientation Control. Right now we don't have that set up in the radio. You can see on the tab on the screen that it is set to course lock. How we're going to set this up is to hit link. We're going to go down to function, scroll down the page, and go to channel 6. And we want to pick what switch we like this to be on. I like mine to be on channel SG, right here, this other 3-position switch. See, right now it's not doing anything. So we're going to go to SG and select it. And you see on the screen we move to home lock. In the center we have course lock, and all the way towards us we have off. Now I want that reversed. I want off to be all the way away from me, course lock in the middle, and home lock to be towards me. So we need to reverse channel 6. How we're going to do that is back out. We're going to go to reverse and go over here to channel 6. Reverse, yes, we want to do that. We're going to back out, and we should be good to go. We have the switch all the way away from us. It's turned off on the screen. You see when we move to the center position, we get course lock. All the way towards us, we get home lock. That's exactly the way I like it. On this particular setup, we don't have to adjust our endpoints like we did with our mode switch. If we needed to adjust our endpoints, then we do it exactly the way we did with our mode switch. But for right now, this one's showing good to go. Next, we're going to move over to gimbal. You can see that we have the gimbal on or off. To be able to use S-Bus/D bus with Futaba's S-Bus and Naza's D bus, and have control over our gimbal, we're going to be plugged in to our F ports on the front. We're going to be plugged into F port 2 for pitch. We have pitch assigned to our right slider right here. So we need to make sure to turn on the gimbal on the screen here so that we can have control over our gimbal. If you set up your radio and your aircraft and you realize, that we went through all these steps and your gimbal's not functioning, you probably have the pitch port plugged into F1 by mistake, or you haven't turned on your gimbal switch. So make sure to turn on the gimbal switch and you should be good to go, and you're plugged into F2. Next, we're going to go over to voltage. This is always set up for your particular aircraft. For this one, a lot of guys now I hear are flying with the protection, voltage protection off. I like to have it just so I can have a visual cue for my LED on the back what my voltage is going to be in case I'm flying line of sight and I don't have my OSD going. So I'm going to turn on my voltage protection. Right now this is a 6-cell setup, so we've got a 24.6 volts showing. We have a 6-cell LiPo chosen. If you're running a 3-cell or 4-cell setup, you just go down and select it. We've got a 6-cell. So with no load on the battery, we want our first level of protection with this particular 6-cell to be at 21.5 volts, where we're calculating a 0.6 volt loss under load, which should give us 20.9 under load. So what that means is that we will see on the back of the aircraft, on our LED back here, a yellow flash to let us know that we've hit our first level of voltage and that we need to be getting our butts home to come land this particular aircraft if we're flying line of sight. If you're flying with the FPV gear and you've got the IOSD plugged in, then your battery's going to start flashing. Your battery symbol up in the upper left is going to start flashing to let you know that you've hit that first indicator. If you make it down to the second level, I always drop that down 0.2 of a volt. So we've got 21.3 with no load, 0.6 loss, and under load 20.7. Because if you hit that safeguard, you're going to start to descend. A lot of guys are just taking this completely out because I'd rather it just have some control of their aircraft as they're coming down. I prefer mine to go ahead and land if it can. Usually if I'm flying under the goggles or on the screen, I've got the IOSD going. I can see when that battery starts flashing at me, and I constantly monitor my voltage. If I'm flying line of sight, then I'm going to turn the aircraft over so often so I can make sure to see the LED and see that I've hit that first level of voltage. And I'm going to start getting the aircraft back or getting it to a safe place for me to land. But if I've got an expensive camera on there, then I want it to start to land instead of just falling. If you run it down all the way, then the aircraft is just going to fall. Next tab is going to be limits. If you'd like to set yourself limits in here, we've got a max radius of 2,000 meters and a max height of 2,000 meters. We're flying off 2.4 control, so there's no real point in trying to exceed that. We have some aircraft set up for UHF, and we just take these limits off so that we can go to the limits of that UHF, or at that point it's usually the limits of the battery. Next we're going to go up to the tools. Up here you can reset your BTU and see if your IMU needs to be calibrated and make sure that the aircraft is good and level. You can check your status. It'll tell you if it needs calibrated or not. This one doesn't need to be calibrated, so okay, if it needs to be calibrated, you can do the basic calibration. Just make sure your aircraft is good and level and hit that, and it will go ahead and do its basic cal and save that for you, so you'll have a good flying aircraft. If you ever notice that the thing is flying a little crazy, go through and check that. Make sure your IMU is good and level and set. You don't need to recalibrate it, and make sure that you do a good compass cal on your aircraft. A lot of times compass the compass in there will get a little offset, and that will account for a lot of yaw issues, or you have a motor that's slightly off angle from the others. The next tab is upgrade. Everything we have on this particular aircraft has been upgraded and it's good to go. You see no updates found, no firmware updates, so we're going to exit out. And then our info. So we're going to go back to the view tab, and you can see we have our GPS location in here set. We have our quad set, our receivers on D-bus, motor idle speed is recommended, idle cutoff is intelligent, fail safest to go to home, intelligent orientation control is on, gimbal switch is on, our voltage protection is on, our current voltage is 24.57 volts, battery type is 6 cell, first level protection, second level protection on our battery, and then we have our mode switch, our camera tilt switch, and our sticks. You see everything is moving and working the way it should. The next thing we're going to do is to go outside. We'll disconnect the aircraft from the computer. We're going to do a hard reset on the power. We're going to shut it all down, bring it all back up, and then we're going to do a compass cal. When we do the compass cal, we're going to take our mode switch and we're going to rotate it back and forth very quickly, 7 to 10 times. You'll see your LED go solid yellow, and you do your DJI compass cal. If you need to see an example of that, we have that at the end of our Spectrum training video, or Spectrum programming video. Alright, well, this has been Kevin with AGL, and this has been programming your Futaba radio 14SG or 8FG, should work the same, with Naza V2. We thank you for watching.